Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video on the chapter of polygons where I will solve the problems of exercise 14a from the textbook of author RS Aggarwal. If you have not watched the previous video, that is part 1, where I discussed about the polygons, the theoretical concepts of polygons, regular polygons, and the formulas related to the exterior and interior angles of polygons, regular polygons, then I strongly suggest that you watch the previous video, that is part 1 video of in this playlist, so that you have a good understanding of the chapter of polygons. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of exercise 14a on the chapter of polygons from the textbook of author RS Aggarwal. Okay, I have the problems of exercise 14a on the left hand side. I hope the fonts are big enough so that you can read them properly. On the right hand side, I will solve the problems. Okay, so let's start solving the problems. Question number 1, these are all subjective questions. Uh, so question number 1 says, find the measure of each exterior angle of a regular pentagon, hexagon, heptagon, decagon and a polygon of 15 sides. So we know that for a regular polygon of n sides, uh, each exterior angle, all the exterior angles are equal and their value is, each exterior angle is equal to 360 divided by n, this much degree is the value of, is the measure of each exterior angle of a regular polygon of n sides. Okay, now we will use this concept or formula to find the measure of each exterior angle of the given regular polygons. So pentagon we know is a regular polygon having 5 sides, 5 equal sides and 5 equal angles. So n is 5. Now let's say we name the each exterior angle to be E, or let's say angle E. Let angle E represent each exterior angle of a regular polygon. So for pentagon, which is a, for a regular pentagon, which is a regular polygon of having 5 sides, we have the each exterior angle will be equal to 360 divided by 5, this much degree, which is equal to 72 degree. Now if I am doing any kind of, if I do any kind of calculation mistake in finding the angles or any other thing, I will not, I'm not really focused in that. If I make any calculation mistake and come up with the wrong result or solution, answer, please let me know in the comment section. I will appreciate that. Okay. So a regular pentagon, the measure of each exterior angle of a regular pentagon is 72 degree. Then is the hexagon. Now these are all easy. You just have to apply the formula 360 divided by n, where n is the number of sides of the regular polygon. For hexagon, we know n is equal to 6. Therefore, angle E will be equal to 360 divided by 60, this much degree, which is 60 degree. Okay. Phi is the heptagon. Now heptagon is a polygon having 7 sides, that is n is equal to 7. So for a regular heptagon, the measure of each exterior angle will be equal to 360 divided by 7, this much degree, which is equal to 551 and 3 by 51 and 3 by 7 degree. Okay, 4 is a decagon. Now decagon we know is a polygon having 10 sides, n is equal to 10. So for a regular decagon, the measure of each exterior angle will be equal to 360 divided by 10, this much degree, which is equal to 36 degree. And the last one is a polygon with a 15 sides, that is a regular polygon with n equals to 15. So the measure of each exterior angle will be 360 by 15, this much degree. This is equal to 230 and 10 upon 15 degree. Sorry. This is this will be, I think, 24 degree. So this is 24 degree, that is a regular polygon having 15 sides. The measure of each exterior angle is equal to 24 degree. So that was question number 1. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Let's do question number 2. Question number 2 says, is it possible to have a regular polygon each of whose exterior angles is 50 degree? Okay. So it's given that there is a regular polygon where each exterior angle, I am representing the angle E as each exterior angle of a regular polygon. So this is given 54 degree. Now to verify or see whether any regular polygon exists which might have each exterior angle equal to 54 degree, we need to consider that, let's say that polygon having n number of sides has each exterior angle equal to 54 degree. So let's assume the regular polygon has n sides and also having each exterior angle equal to 54 degree. So this implies we must have angle E must be equal to, as per the formula, 360 by n. This implies this much degree. This implies the measure of each exterior angle is given to be 54 degree. So we can say 54 degree is equal to 360 by n, this much degree. So now we can say, we can ignore the degree, we can say 54 is equal to 360 by n. So this implies n will be equal to 360 divided by 54. Now n is a number of sides, it is a natural number, it cannot be a fraction, it has to be a natural number, and of course n has to be greater than or equal to 3, since we know that the minimum number of sides for a regular polygon or even a polygon is 3. So n has to be greater than or equal to 3. Now what is 360 by 54. 360 by 54, I don't think 54 exactly divides 360. So, uh, 7, no. I think it's 6. Uh, 54 multiplied by 6 is 24, 30, 32. So, this is um, 636 by 54. So, this is not a, we can see that 360 by 54 is not a natural number, it is not a whole number. 360 by 54 has to be a natural number and greater than equals to 3. Then only we can say that the polygon, a regular polygon exists, which will have 54 degree as a each exterior angle. So, and so we see that n is coming out to be 360 by 54, which is a mixed fraction, which is not a whole number. N has to be a whole number greater than equal to 3, since n represents the number of sides of a polygon. So, therefore, this implies not possible. This implies angle E, exterior angle of 54 degree is not possible. Okay. Question number 3. Find the measure of each interior angle of a regular polygon having 10 sides and 15 sides. So, we know two properties regarding each exterior angle and interior angle of a regular polygon. We know that for a regular polygon, each exterior angle, all the exterior angles are equal and all the interior angles are also equal. So, for a regular polygon of n sides, we know that each interior angle will be equal to, we know, 180 degree minus each exterior angle is 360 by n, this much degree. If we simplify, if we take out 180 as common, we get 180 1 minus 2 by n, this much degree. This is equal to 180 multiplied by n minus 2 whole divided by n, this much degree, where n is the number of sides of the regular polygon. So, this is the formula for each interior angle of a regular polygon of n sides. So, now let us find the interior angles of the given polygons, regular polygons. So, first is n is equal to 10. This implies, now let's name each interior angle to be angle I. Angle I represents, I am just assuming angle I represents each interior angle of a regular polygon. So, angle I will then be equal to 180 multiplied by 10 minus 2 whole divided by 10, this much degree. This is equal to 180 multiplied by 8 divided by 10, this much degree. This is equal to 18 multiplied by 18 degree. This is equal to 144 degree. Wait a second, no, okay, fine, 144 degree. So, each interior angle of a regular polygon having 10 sides is equal to 144 degree. Let's do what will be for n equals to 15 sides, n equals to 15, this implies each interior angle will be equal to 180 multiplied by 15 minus 2 divided by 15, this much degree. This is equal to 180 multiplied by 13 divided by 15, this much degree. This is equal to 12 into 13 degree, and this is equal to 156 degree. So a regular polygon, each interior angle of a regular polygon having 15 sides is equal to 156 degree. So that was question number 2. Question number 3. Let's do question number 4. Question number 4 says, is it possible to have a regular polygon each of whose interior angle is 100 degree? So it is asking if each interior angle is equal to 100 degree, is this possible? That is, if any regular polygon of some number of sides exists that has each interior angle equal to 100 degree. So as usual, as before, let's assume a regular polygon. Let's assume a regular polygon of side n has interior angle, each interior angle equal to 100 degree. So this will imply, we know that each interior angle of a regular polygon having n sides is equal to 180 multiplied by n minus 2 divided by n, this much degree. Okay, so this will imply the left hand side is interior angle which is given to be 100. So we have 100 degree is equal to 180 multiplied by n minus 2 divided by n, this much for degree. If we now ignore the degree, we get a linear equation in n, that is 100 is equal to 180 n minus 2 divided by n. From here we need to solve for n and see if we can get a value of n which must be a natural number or a whole number greater than or equal to 3. So if we do cross multiplication, we have 100 n is equal to 180 multiplied by n minus 2. Okay, if we further simplify, we get 100 n is equal to 180 n minus 360. This implies if we bring all the n terms to the left hand side, all the n terms to the right hand side and all the constant terms to the left hand side, we get 360 is equal to 180 n minus 100 n, which is equal to 80 n. So this implies n is equal to 360 divided by 8. 360 divided by 80, which is equal to 36 by 8, and we can clearly see that 36 is not exactly divisible by 8. So this will be 4 and half. So not equal to a whole number. Not equal to whole number. This implies we can say no n exists, no n greater than equal to 3 exists for an interior angle equal to 100 degree. Therefore, uh, interior angle of 100 degree is not possible for a regular polygon. So this is not possible. 100 degree, a regular polygon cannot have an interior angle equal to, each interior angle equal to 100 degree. Okay, let's do question number 5. What is the sum of all interior angles of a regular pentagon? Now, I think I am doing some mistake. Each interior angle I is equal to 180 into n minus 2 divided by n. Yeah, that is fine. Okay. So question 5 is, what is the sum of all interior angles of a regular pentagon, hexagon, nonagon and a polygon of 12 sides? So we need to first remember what is the sum of all interior angles of a regular polygon of n sides. What was the formula? I think 180 into n minus 2, sum of all interior angles. For a regular polygon of n sides, sum of it is asking sum of interior angles. For a convex polygon, the sum of all exterior angle is equal to 360 degree, and also for a regular polygon, the sum of all exterior angle is equal to 360 degree. So the sum of all interior angles will be the sum of interior angles. Let's say this be, I am denoting it with the angle SI, that is sum of interior angles. Sum of interior angles. Even though this seems to be a weird angle, but anyway, let's say angle SOI means the sum of interior angles. The sum of interior angles, what is the formula? What is the formula? A regular polygon of n sides. Now the value of each interior angle of a regular polygon of n sides is 180 multiplied by n minus 2 divided by n. 180 multiplied by n minus 2 divided by n is the value of is the measure of each interior angle of a regular polygon of n sides. So definitely the sum of all the interior angles will be this multiplied by n. So this becomes 180 multiplied by n minus 2 this much degree. Okay. Now let's see for a pentagon. For a pentagon, we know it is a polygon of having 5 sides. That is n, capital N, it will be equal to 5. So angle SOI for a pentagon, that is angle SOI means the sum of all the interior angles will be equal to 180 multiplied by n minus 2, n is 5, so 5 minus 2 this much degree, this is equal to 540 degree. 540 degree. Okay. Second is octagon. Now second is hexagon. Hexagon is a polygon of having 6 sides, n equals to 6. So the sum of all interior angles SOI, angle SOI will be equal to 180 multiplied by 6 minus 2, which is equal to 720 degree. Okay. Next is the nonagon. Nonagon means a polygon with having 9 sides, that is n is equal to capital N is equal to 9. Therefore, the sum of all the interior angles of a regular nonagon will be equal to 180 multiplied by 9 minus 2, which will be equal to 1260 degree. 180 multiplied by 7, which is 1260. Okay. The next is a polygon having n equal to 12 sides. N equals to 12. Therefore, sum of all interior angles will be equal to 180 multiplied by 12 minus 2. This is equal to 1800 degree. Okay, so that was question number 5. Let's see what is question number 6. What is the number of diagonals in a, okay, so the number of diagonals in a heptagon, we know that number of diagonals of a polygon of n-sided, that is then having n number of sides, n-sided polygon is there is a formula n multiplied by n minus 3 divided by 2. This is the number of diagonals in a polygon of n sides. So now let's find the number of diagonals in a heptagon. Now, what is the heptagon? Heptagon is a polygon having 7 sides. So, the number of diagonals be named as NOD. NOD stands for the number of diagonals. So, for a heptagon, we will have NOD is equal to 7 multiplied by 7 minus 3 divided by 2. This is equal to 7 multiplied by 4 divided by 2. This is equal to 14. So, there are 14 diagonals in a heptagon. Next one is octagon. Now, what is an octagon? Octagon is a polygon having 8 sides. So, n is equal to 8. So, this implies NOD, that is number of diagonals of a polygon with n sides, with 8 sides, will be equal to 8 multiplied by 8 minus 3 divided by 2. This is equal to 8 multiplied by 5 by 2. This is equal to 20. There are 20 diagonals in an octagon. Okay. Next one is for a polygon having 12 sides, n is equal to 12. This will imply the number of diagonals will be equal to 12 multiplied by 12 minus 3 divided by 2. This is equal to 6 multiplied by 9. This is equal to 54. So, a polygon having 12 sides has 54 diagonals. Okay. Let's do question number 7. Find the number of sides of a regular polygon whose each exterior angle is measures. Okay. So, we know that the formula of each exterior angle of a regular polygon of n sides is equal to 360 divided by n, this much degree. So this is the relation between each exterior angle and the number of sides of a regular polygon. So let's find what is the number of sides of the regular, what is n, where for a, when e is, it is given that the exterior angle is 40 degree. So this will imply, now from here we can say that n is equal to 360 by angle E, 360 degree by angle E. So when E is exterior angle is 40 degree, we can say n will be equal to 360 degree by 40 degree. This is equal to 360 by 40. This is equal to 9. That is, the exterior angle, each exterior angle is 40 degree for a regular polygon of n 9 sides. Next one is given each exterior angle is equal to 36 degree. So this will imply n is equal to 36 degree divided by 360 degree divided by 36 degree. This is equal to 360 divided by 36, which is equal to 10. So a regular polygon of 10 sides has each exterior angle equal to 36 degree. Next one, angle E is given, or each exterior angle is given to be 72 degree. So we can say that n will be equal to 360 degree divided by 72 degree, which is equal to 360 divided by 72, which is equal to 5. Next one, angle E is given to be 30 degree. That is, each exterior angle of a regular polygon is given to be 30 degree. Then what will be n? So we know that n will be equal to 360 degree divided by each exterior angle, that is 30 degree. This is equal to 360 divided by 30. This is equal to 12. Okay. Let's do question number 8. For question number 8, we have a figure. A polygon is given. Let's quickly draw the figure. So, a polygon is given and some exterior angles are given. We have to, there is an unknown angle, unknown exterior angle x, we have to find x. So, let's see what is the polygon first. Draw the polygon. A, B, then we have C. This is the ABCD. This is the given polygon which is having 4 sides. So it's a quadrilateral. Now let's quickly, some exterior angles are given. This exterior angle is given to be 50 degree, and this exterior angle is given to be 90 degree, and this exterior angle is given to be 115 degree, and it is asking to find what is this exterior angle. So basically we are given for this quadrilateral, which is a polygon of 4 sides, all the exterior angles are given, only one unknown exterior angle we need to find, that which is x. So clearly we know that the sum of we know that for a polygon, the sum of the exterior angles is equal to the sum of, we know that sum of exterior angles of a polygon, that is a convex polygon, is 360 degree. Sum of exterior angles is equal to 360 degree. Now, what is the sum of all the exterior angles for this for the given polygon? If we add up all the exterior angles, we get 90 degree plus 50 degree plus 115 degree plus x degree, so x is an unknown, is equal to 36 degree. If we ignore the, now if we can ignore the degree, and we get 90 plus 50 plus 115 plus x is equal to 360. If we simplify the left hand side, add up all the constants in the left hand side, we get 90 plus 50 is 140, 140 plus 115 is 255 plus x is equal to 360. This implies x is equal to 360 minus 255, which is equal to 105. So this angle unknown angle is 105 degree. Okay. Let's see question number 9, which is the last problem. Find the angle measure x in the given figure. So we are, as we can see, we are given a regular polygon of 5 sides. So which is a regular pentagon. So we are given kind of this 1, 2, 3, 4. I'm sorry for my bad drawing, but consider this as to be a regular pentagon. A, B, C, D and E. In the figure it is given, it is as you can see, all the sides are marked with a single stroke, which means that the length of all the sides are equal, which means that it is a regular polygon, and we can clearly see there are how many sides? N is equal to 5. In the given figure we can see there are 5 sides, so n is equal to 5, and we need to find this angle, which is this angle. Now clearly we can see that angle, all the interior angles, since all the sides are equal, it has to be a regular polygon, so which also means that all the interior angles will be equal. So angle D will be equal to angle E, will be equal to angle A, will be equal to angle B, which is x degree, will be equal to angle C. Now, what is the formula for what is the value of each interior angle for a regular polygon of n sides? We know that each interior angle, the value of each interior angle of a regular polygon of side n is equal to, what was the formula? It was actually 180 degree minus the value of each exterior angle, that is 360 degree divided by n. This is equal to 180. If we simplify this, this will be 180 multiplied by n minus 2 divided by n. So this is the formula for the measure of each interior angle of a regular polygon of having sides n, capital N. Now for this figure we know the n is 5. So this will be equal to 180 multiplied by 5 minus 2 divided by 5, this much degree. This is equal to 36 multiplied by 3, this much degree. This is equal to 108 degree, 108 degree. So this means that x is equal to 108. Remember, x is not 108 degree but 108, since in the given figure it is already the angle, the measure of the angle is already given to be x degree. So x will be a number, that is the value of an angle. So x is 108, or the measure of each interior angle of the given polygon, which is of the given regular polygon, which is a regular pentagon, is 108 degree. Okay, so this brings to an end in solving the problems of exercise 14a on the chapter of polygons. The next exercise 14b are objective questions which I will solve in the next video. So please stay tuned for that. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Tomorrow I will solve the MCQ problems of exercise 14b, and once that is complete, let me quickly check if there is any test paper on this chapter. No, there is no test paper. So after completing the solving the exercise 12b, I will I will try to make, if not two, but at least one assignment problems on this chapter of polygons in this playlist, and either one or two, and then I will also prepare and solve 5 good problems, relatively harder problems, in the other playlist, that is Maths 8 Hot. So please stay tuned for these upcoming videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.